Hello students, in the previous modules we discussed Newton's first law of motion, second law of motion. Now we are going to discuss Newton's third law of motion and conservation of momentum. Next we have to discuss Newton's third law of motion. See the inflated balloon. When you release the air inside this balloon will move in the upward direction. Why the balloon is moving in the upward direction? Because the air escapes in the downward direction. This air pushes the balloon in the upward direction. Then you know that how we are walking. Another example. Because you know that when we are walking, we are pushing the floor in the backward direction. Then the floor pushes us in the forward direction. That way we are able to walk on the floor. This is the reason you know that that means smooth floor you cannot walk properly. That means the reaction force there it is less. Another example, a person jumps from the boat to the shore. The boat moves backward and the person moves forward. The person pushes the boat in the backward direction and the boat pushes the person in the forward direction. The person pushes the boat in the backward direction. This is action. And the boat pushes the person in the forward direction. This is reaction. Here the action and reaction both are equal and opposite, but it acts on two different bodies. According to Newton's third law of motion, every action there is an equal and opposite reaction. Some more examples you can see here. How the person swim in water. You know that when he is swimming, he is pushing the water backward. Then the water pushes him in the forward direction. During swimming, we push the water in the backward direction with our hands or feet to move in the forward direction. It is the reaction to this force and pushes us forward. Another is working of jet planes and rockets. That is also an example for Newton's third law of motion. Say the fuels burned inside goes downward, it pushes the rocket in the upward direction. So here also the Newton's third law works. I already told you, while walking on the ground, we push the ground with our foot in the backward direction. This is the force of action. In return, the ground exerts an equal force of reaction on our foot in the forward direction. The force that actually makes us to walk in the forward direction is this reaction force. When the gun fires, you know that the gun moves backward. That is the recoil of the gun. That is the reaction due to the accelerating force of the bullet. Accelerating force of the bullet, that is action. Two more examples for third law of motion. This spring balance is attached to the wall. It is fixed. Then from the other spring balance, if you pull it in this direction, you can say that the reading of both the spring balance is same. This shows action and reaction are equal and opposite. Next, the force of reaction appears so long as the force of action acts. So it always in pairs and simultaneous. Next, we are going to discuss conservation of momentum. We are going to derive the relation between the momentum of two objects before collision and after collision. Here see two objects MA and MB. The initial velocity of MA is UA and MB is UB. Both are moving in the same direction. The velocity of MA is greater than the velocity of MB. After some time, they collide each other. Then, this is the collision. Then what happened? After the collision, the velocity of A changes to VA and the velocity of B changes to VB during the time interval T. That means the object A exert force on B, that is the action. Then the object B exert force on A, that is the reaction. So we already discussed what is Newton's third law. Every action there is an equal and opposite reaction. Here we will see how much is the action force and how much is the reaction force. Then we will equate both by using Newton's third law. Then we will see the relation. The force exerted by A on B, that is FAB, and the force exerted by B on A, that is FBA. Now we will see how much is the rate of change of momentum of the ball A, that is MA into VA minus UA upon T. That is similarly the rate of change of momentum of the ball, that is VBA, that is MB into VB minus UB upon T. So you know that FAB is equal to MA into VA minus UA upon T. Then FBA is equal to MB into VB minus UB upon T. But you know, action is equal to minus reaction. Why? Because action and reaction are equal, but it is opposite. So FAB is equal to minus FBA. So when we equate these two and simplify, you will get MAUA plus MBUB, that is equal to MAVA plus MBVB. This is the initial momentum of the object A. This is the initial momentum of the object B. This is the final momentum of the object A. And this is the final momentum of the object B. That means the total momentum before collision is equal to total momentum after collision in the absence of external force. The total momentum of the two balls before collision is their total momentum of after collision. We observe that total momentum of the two balls remains unchanged or conserved provided no other external force acts. This is conservation of momentum. Gun firing is an example for conservation of momentum. Total momentum before firing is equal to total momentum after firing. When we apply conservation of momentum here, we can say that the total momentum before firing is equal to total momentum after firing. Here V is the recoil velocity and small v, this is called muzzle velocity of the bullet. Here the total momentum after firing, that is mv plus mv. Then the total momentum before firing, mu and mu both are 0. From this equation we can calculate what is the recoil velocity of the gun.